Alright, so now page 129, number 3. So we have this diagram, W, X, Y, Z, angles 1, 2, 3, 4. We're starting out being given that WX is congruent to YZ and ZW is congruent to XY, and we want to show that the bottom is parallel to the top. Okay, so we have to refer to our theorems about proving that lines are parallel. Okay, if we're going to prove the lines are parallel, what have we learned? We've learned that we need to know about angles. So notice we can get this by asking questions. How do we show lines are parallel? By knowing that angles are congruent. Okay, well, how do we know angles are congruent? Well, these angles are they're all parts of a triangle. So if we could show triangles are congruent, then we're good to go. So notice we can figure out what to do by asking and answering questions. It's an important skill, as we've talked about. So we know lines are parallel because angles are congruent. And we know angles congruent because triangles congruent. Ask and answer questions and you can figure this out, and it helps you pull out information from your mind that you already know. It gives you direction so you don't just look at this all confused. So that's what we're going to be doing in our proof. Okay. If we get triangles congruent, then we know angles are congruent. If we know angles are congruent, then we know lines are parallel. So that's our strategy. If you want to write that down somewhere, stop the video, write that down. Keep track of what we're doing. So let's go and do the proof. Alright, so as usual, state the given. We have WZ congruent to YX and WX congruent to ZY. And that's given. Okay, so remember the first thing we need to do is show triangles are congruent. To do that, we've got to look at the different ways we can do that. So we could do ASA, SAS, or SSS. Because so far in our book, those are the only theorems we've learned. So those are our choices. So if we look at this, we don't know anything about the angles, so probably these are out. We might have to see that we're wrong and we can use one of those, but right now it looks like we can't. Then if we look, the sides, this triangle and this triangle, and hey, dang, look what happened. My finger traced over the side in both triangles. That tells me it's included in each of them. It's the same thing. It's reflexive again. So we're going to use side, side, side. Okay? So we see that XZ is congruent to itself by identity. And then we've got triangle XWZ is congruent to triangle, so XWZ, ZYX, so XWZ, 2 and 1, ZYX, okay. and that'd be the Sss theorem. Okay, and now we know that this line will be parallel to this one if alternate interior angles are the same. 3 and 4 don't matter because they're made up of extra lines. You know, only 2 has this in it, and only 1 has this in it, and 1 is right here, and 2 is right here, and we traced over this both times. So that's what they have in common. That'd be our transversal. So angle 1 congruent to angle 2 by CPCTC. When we have congruent triangles, then parts of those triangles are congruent, the corresponding parts, because 1 and 2 are in the same place. It can't just be anything, but notice 1's between the 2 and the 3 marks, and so is 2. I got the double mark and the triple mark, the double and the triple, and that's how I know that they're corresponding. Okay, so they're the same. And then, last step, we know ZY is parallel to WX by the alternate interior angle theorem. Remember, when alternate interior angles are congruent, then the lines are parallel. Okay, so alternate interior angle congruent implies parallel. All right, good. It's number 3. Now number 4 will be similar. We're going to use the same diagram. We'll repeat some of the same steps, but so it doesn't seem confusing, I'm just going to do the proof separately, redraw the diagram. So W, X, Y, Z. Then we got 1, 2, 3, 4. Okay, so number 4, as you see, we're given a parallelism and a congruence. And then we want to prove something else is parallel. So ZW is parallel to YX. Remember, we mark that with an arrow, and that shows that they're going in the same direction. Okay, it's something you'll have to get used to and memorize. And ZW is congruent to XY. So they go in the same direction, and they are congruent. Okay, and then we want to show that the top is parallel to the bottom again. So let's put down the given. ZW parallel XY, and I guess it's not the same as the previous. I thought it was going to be, but it's not. And then WZ is congruent to XY. So that's our given. Now, we want to end up with parallel lines, so we ask ourselves, how do we show lines are parallel? And of course, we know that if we think, look back in the book, we know it's by showing angles are congruent. So lines are parallel because angles congruent. Okay, well, how do we show angles are congruent? Well, maybe if we had parallel lines, but that might help. Or if triangles are congruent. So we need to do something with this stuff so we can show angles are the same. And and then in turn show some other lines of parallel. It's going to be our strategy if you want to write that down. So let's see. If this line is parallel to this one, then with the lettered stuff, you know, if we got the parallels in this transversal, we have a Z shape, and inside the crux of the Z, remember the angles are congruent. So we know 3 and 4 are going to be congruent. So from the parallelism, we know angle 3 is congruent to angle 4. And that's parallel implies alternate interior angle congruence. And then, hey, cool. If we think of angle 3, it's right here. Angle 4 is right here. What do we trace over twice? Well, this line. So these two make up angle 3, so notice it's side, angle, side. The angle between these two sides, or made up by it. Same thing with angle 4. It's made up of these two sides that we've got marked. So it's like this. These sides make up angle 4. And so we'll be able to use, of all our theorems, we got side, angle, side. The included angle. Okay, so we're going to mark down the side first. XZ congruent, XZ, and that's identity. Or you can call it reflexive. And then as we've seen, we know triangle WZX is congruent to triangle YXZ. Let's see, WZX, YXZ, okay, and that's side angle side congruence theorem. And then we know that because we showed the triangles are congruent, we know the parts are congruent, corresponding parts. So angle 1 here, opposite this side, and angle 2, opposite this side. They're kind of in the same place. If we got the bottom triangle and rotated it, angle 1 would come up here. So they're corresponding. So angle 1 is congruent angle 2, and that's the thing we've seen every time so far, CPCTC. Corresponding parts of congruent triangles are congruent. The parts are congruent. The angles are congruent. And then, since this equals this, then we know that we got this Z shape here. And the crook inside the Z, the crooks are congruent. So the top and bottom are parallel. So YZ is parallel to WX. And that's congruent, alternate interior angles, implies parallel. Done. Alright, then we'll do 5 and 6 in another video.